This video is over chapter 44, Parametric Equations and Tangents. And this is the first video. And in this video we're going to look at examples 259 and 260. So, the moral to the story here in this chapter is that when you have x and y defined in terms of a parameter t, so you have your parametric equations, your curve is defined in terms of these parametric equations, then the derivative of y with respect to x, or the rate of change of y with respect to x, is the derivative of y with respect to t divided by the derivative of x with respect to t. And so here are the equations, and we want to find the equation of the tangent line at the point where t is pi over 2. So we start by calculating the derivative of y with respect to x, which is a derivative of y with respect to t divided by the derivative of x with respect to t. X is t times sine squared of t, y is t times cosine of t. So the derivative of x with respect to t, the derivative of y with respect to t, these are calculus 1 problems. So we have the derivative of y divided by the derivative of x. T is pi over 2. Okay, so now we want the equation of a line. We need an x-coordinate, a y-coordinate, and a slope. T is pi over 2. That gives us the x-coordinate. So we substitute pi over 2 for t, so x is pi over 2. When t is pi over 2, y is 0. To find the slope, we have the derivative of y with respect to x. We substitute pi over 2 in for t up here. It's not too bad because sine of pi over 2 is 1 and cosine of pi over 2 is 0, so this simplifies rather nicely to negative pi divided by 2. Finally, we have the equation of the line. As I said, you need an x-coordinate, a y-coordinate, and a slope. So we have y minus the y-coordinate is equal to the slope times x minus the x-coordinate. The second example is similar. We have our curve given in terms of these parametric equations. We want to find the equation of the tangent line corresponding to the point where t is equal to 2. Again, the derivative of y with respect to x is the derivative of y with respect to t divided by the derivative of x with respect to t. Calculate the derivative of y with respect to t, the derivative of x with respect to t, and we simplify. T is given as 2. Again, we need an x-coordinate, a y-coordinate, and a slope. T is 2. X is e squared. Y is natural log of 2. The derivative of y with respect to x is 1 divided by 2 times e squared. This is our slope. So we have y minus the y-coordinate is equal to the slope times x minus the x-coordinate.